So in today's lesson, we're going to be talking about the midpoint of a line segment. So we're going to start with some fairly straightforward examples. When we say midpoint, mid, I think you can deduce, means middle, and point defines a coordinate along that line segment. So if we were looking at, and I wanted to pick some really simple, straightforward examples for you to make sense of why we're able to do what we do as we move forward. So take a look at the blue line, AB. I want you to just take a look at it and tell me where you would put the midpoint. And then I want you to take a minute and locate the midpoint of this red line, this vertical line CD. Okay, so I'm expecting that the points that you chose were right here and then right here, right? And so how did you go about that? Did you guesstimate? I'm guessing you didn't. My guess is that you saw that my line over here starts at x equals -4 and ends at x equals 8. And you thought about that and you thought, well, where is the exact point in between there? Well, that's going to be at x equals 2, really, right? So to find the midpoint of that line segment, you probably, whether you really thought about it deeply or not, aim to find, the average between the two endpoints, if that makes sense. And then we probably did something very similar, except in the vertical direction, by looking at CD beginning at, y equals 2, and y equals -6, and seeing that y equals -2 falls exactly in the middle there. And that's if we want to be specific, right? So now, doing this with vertical and horizontal lines is fairly straightforward, but we're likely going to see scenarios where the lines are not going to be horizontal or vertical. So we need to have a better strategy to enable us to figure these types of problems out. So that's what we're going to be looking at today. So in the last examples, we saw that we essentially took the average between the endpoints. And so things don't change too drastically when we start to look at line segments that are not vertical or horizontal. We can sort of think of it in the same way by looking at, the average between the endpoints, but sort of breaking them down into x and y components. So I'm just going to draw in. We know that to get from, I'm going to call this point A to point B, I know that I needed to go down a certain amount in my y direction, and I needed to go down or over a little bit in the x direction. And so I can do the same by breaking this down into components. So in the x direction, I'm going from, I need to find the average between -3 and it looks like 8. So I'm going to add those together and divide by 2. That's right. So that's how we find the average in general, right? So let's do the same thing with y. So y, I'm going to do this same approach. I'm going to have 5, find the average between 5 and -1. Those two values. And when I go about and do that, I'm going to get some nice numbers. So 5 divided by 2, 2.5. And I'm going to get that my y-coordinate of the midpoint is going to be 2, right? So now I have a coordinate, and let's see if that matches up with what I'm seeing on my graph. So according to my calculations, I should end up with 2.5 and 2. So let's see. Does it look like it's at 2.5? Here's 2.5 and 2. Yes, it does. So, so that's the strategy essentially that we're going to use. We're going to find the average of the coordinates, of the x-coordinates, and the average of the y-coordinates. So for those of you who like to have a nice clean formula for this, this is typically how we represent the formula for the midpoint of a line. Let's take a look at it and make sense of all its components. So remember, the midpoint is a coordinate. It's a point, an xy coordinate on our Cartesian plane. And so, we're going to expect to have an x component and a y component. So to put that in a formula, all we're doing is we're saying, well, what did we do to the endpoints? We took the x components, added them together, divided by 2. We took the average. And then we did the same thing to the y components. And then that gives us a nice coordinate to work with. Let's put this formula into action by looking at some problems. Okay, so in the first example that we saw, we had that nice visual, right? We had the line segment on the graph, and they actually had the midpoint identified for us. And so that can make it easy. And also the numbers were nice and friendly numbers to work with. In this case, the numbers are fairly friendly, but we don't have the visual to accompany. So this is where, you know, the formula, or thinking about why the formula makes sense, is a helpful thing to do. So I'm going to go ahead and solve this, but I'd like you to also pause the video and give the question a try on your own, and then we'll kind of connect in a few seconds and check out the solution, just to make sure that you're understanding what you're supposed to be doing. Okay, so here I've solved the problem. I'm hoping that you did the work yourself and that you can follow along. So I labeled point A as my x1, y1 coordinate. I could have, that's arbitrary, I could have, you know, flipped these, and I named coordinate B x2, y2. But again, yeah, I could have flipped those around. That just really doesn't matter. And then I just substituted the x values and the y values into the formula for midpoint, and then solved, and there's my coordinate. So that I would consider to be sort of an entry-level question. Hopefully you found that to be straightforward and that you didn't struggle with it. Some of you may be wondering, well, do we have to evaluate the point to get a decimal? No, not necessarily, right? Like, this is a nice round sort of, this decimal is non-repeating, which is nice. I would say that because it's, you know, we're all going to have these values divided by 2, then that's always typically going to give us some decent decimals. So feel free to provide either solution. So here's a different type of question. It reads, for line segment GH, one endpoint is G, and they're giving us the coordinate. The midpoint of the line segment is this. Determine the coordinates for H. All right, so this is a different type of question. They're giving us different information to have to solve for. So, I know the midpoint is at 4 and 2, and the endpoint is, so I'm going to just kind of mock up this line just to help you visualize. So they're giving us the midpoint, which is at 4 and 2, and the endpoint, so I'm going to call this end G, and I'm going to call this end H, and we have 6 and 5. And so what we don't know is I'm going to call this x2, and we don't know y2. That's what we really are trying to find out here. So how are we going to go about this? So I'd like you to pause the video and to think about how you might do that, and to try a few things. I'm going to encourage you to do that if you're ready to do it. All right, I'm going to take this up. Let's see how you did with your thinking. So in order to do this, I really need to almost, the first thing I would do is say, well, I have a tool that I can use. Why don't I try to see how I can utilize that tool in order to solve the problem here? And so here's my tool. My tool is the formula for the midpoint. So the midpoint I know is, xm, ym is equal to x1 plus x2 divided by 2, and y1 plus y2 divided by 2, right? And so let's see which pieces of this puzzle that I actually have. Well, I have my midpoint, so that means I have this information. I have that. And I have one of my endpoints, which seems, I could think of this as x1, y1. So I have that information. So I have this and I have this, right? But what do I not have? Well, I don't have information, and I'm looking for this guy and this guy. So my strategy is to separate. I'm going to separate the x and the y parts of this formula, and that should help me solve. I'll show you what I mean. So I'm going to call this step 1, and I'm going to say xm is equal to, so the x-coordinate of the midpoint is equal to x1 plus x2 divided by 2. And I'm going to fill in what I know. Well, I know the x-coordinate of the midpoint is right here, so I'm going to fill that in. And I know that x1 is right here, that's 6, plus x2 divided by 2. And so now I have my unknown here, x2, in a simple one variable equation that I can solve for. So that is exactly what I'm going to do. I'm going to bring my 2 upstairs, and that's going to give me 4 times 2 equals 8. So 6 plus x2. Now I'm going to bring that 6 to the other side, subtract it, and so my x-coordinate of my other endpoint, which happens to be h, is 2. So now I'm going to go ahead and what I'd like you to do, if you weren't able to figure out a process, I'd like you to go ahead and solve for the y-coordinate of that endpoint. Okay, so I've gone ahead and done the work here for us by substituting in all of the known values, and I solved for y2, which is the y component of that other endpoint, and I got -1. So really what that means is that the other endpoint is at 2 and -1. So there we go, and it almost seems like my diagram sort of makes sense. So there we have it. That's how you go about finding the endpoint G or H in a question like this. Hopefully not too challenging once you see the process. So if you've managed well with the questions so far, we're ready to jump into a bigger word problem. So analytic geometry is a section of math where we do quite a few sort of proofs or verifications. And so to know how to do that, there's some key terms, and I'm going to introduce one of them to you right now, and that is bisect. So bi meaning 2 and sect meaning divide. So bisecting means dividing into 2 equal parts. Now, I don't know about you guys, but I remember in elementary school having with my compass and my protractor and all that business, and having to do these little geometry activities where we would start with our compass from one side and then do little marks from each end and then on either side. And what that does is it divides the line in half. So C is essentially the coordinate of the midpoint, and that midpoint delineates the fact that I've divided my line or bisected my line into 2 equal parts. So you may see that word come up in a question, so verify that something or other bisects something else. That means that you're looking to divide the line in 2, which typically means identifying where the midpoint is. Okay, so we're going to get to a different type of question that is a little bit more involved. So it says, verify that the diagonals of a parallelogram with vertices, and they give us the vertices, bisect each other. Now there are a lot of words there, like parallelogram and vertices and bisect, and we need to know, and diagonals. So those are a lot of words, and so an easy way I think to get started into figuring out, well, what the heck is going on, is to actually plot the points. So let's go ahead and do that. So take a minute to just draw a graph and plot some nice points, or even just sketch them out. That will work great. I'm going to do the same. I'll meet you back in a couple of seconds. Okay, so here I am back with you, and I've drawn out my parallelogram. Now this happens to be in a Cartesian plane, but honestly you could just do a sketch and just put the points in. And I would recommend to you actually that you not only just label the vertices or the corners, but that you actually input the data there, just to help you visualize what sides are connected to which, and so on and so forth. Right? So diagonal, let's go through this. So parallelogram, we have a parallelogram here, and we can tell that because we can tell that the sides that are parallel to each other, we have 2 sets of parallel sides there. There's our parallelogram. And the vertices, remember vertices just means corner. But we want to know that the diagonals bisect each other. So diagonal means, you know, we're going to look at the opposite corners. So this is a diagonal here. So QS is making a diagonal, and PR is making a diagonal. And so again, let's not rely on our Cartesian plane. Let's just actually rely on some analytic geometry, and we know that they're going to bisect each other if that point of intersection right there happens to be the same coordinate. So let's do that. So I'm going to first find, this is going to be my strategy, folks. The first thing that I'm going to do is I'm going to find the midpoint for QS. That's my first strategy. So take a minute to do the work for that, and we'll meet up in a few seconds. So let's just take a minute to check our answers so far. Let's see how we did. So I got that the midpoint of QS is 1 and 0. And so now I'm going to know if the diagonals actually bisect each other if the midpoint of QS is the same as the midpoint for PR. So that brings me to the next step. My next step is going to be to find the midpoint for PR. So take a minute to calculate that, and we'll meet up again. Okay, so I've done the work for PR, and I found that the midpoint is indeed the same midpoint. And so that allows us to make some conclusions. We can now say that since PR and QS have the same midpoint, they bisect each other. So here's another really important definition or term that we're going to need to know throughout the rest of the unit, which is median. So in the word median, you can see med or middle again. So what a median is it's a line that basically goes from the midpoint of one side. Here we can see the midpoint of BC in this case, which is that where we're calling D. And it goes from that midpoint to the opposite vertex or the opposite corner. So a couple of things that I want you to notice about it that makes the median unique is, number one, by definition, the median has to bisect the line that it's leaving from, right? So notice these little bars here are indicating that from B to D is the same length as from D to C. It's bisecting. So D is by definition the midpoint. Another thing I want you to notice that is really important is that DA is not perpendicular to BC. So in other words, the median is not necessarily going to be at a right angle to the line that it's leaving from. So you'll see how that will play in when we start to look at other questions that involve not just a median but a perpendicular bisector. We're not there yet. So I'm not going to lie, the next question is a little bit more involved and has a few more layers to it, but I know that you can manage it just fine, and I'm going to break it down for you as best I can. Okay, so this is probably the more complicated type of question you're going to see in this section. So let's just read through it and break it down. So it says, for the triangle with vertices, and here we have the vertices, find an equation for the median. I'm going to highlight that, equation for the median from vertex P. That's also important, from vertex P. So the best way I think to tackle this is to draw a nice sketch. Now again, it doesn't need to be on a graph. If you want to go ahead and do that, you can. I'm going to pause the video and come back with a nice diagram, and you should do the same. Okay, so here is my quick sketch of my triangle. And so it says I want an equation for the median from vertex P. So from vertex P means I'm talking about the median going from this corner down to line QR, and it's going to bisect that line. So I'm going to actually just draw that in. So I'm talking about, I'm going to need to find the midpoint here, which I don't know yet, and I want to know the equation of this line, right? So there are a couple of things that I need if I'm going to find the equation of a line. And the easiest thing to do, I think, is probably to look for an equation in the line y equals mx plus b, right? And so what do I need when I'm doing that, when I'm performing that task? Well, I need my slope and I need the y-intercept, right? And so if I'm looking for slope, well, what do I need for slope? Well, slope means that I need to have two coordinates. So let's take a look at this. Do I have two coordinates? Well, yes, I do. Well, maybe not yet, but I can. So I have, if I want to know this line, I need to have the slope of that line. I need to know two coordinates along on that line. Well, so far I have this one. And another one that would be key would be this one right here. Is there a way for me to find out the coordinate of that? Yes, there is. If I find the midpoint of QR, then that will give me the value, that coordinate right there. And that will in turn allow me to calculate slope. So that is going to be my strategy number one. I'm going to write that down. So number one, I'm going to say we're going to find the midpoint of QR. That's my first strategy. Now, then, what am I going to do? Why did I find the midpoint of QR? Well, that was to find the slope of PM. So I would say find the slope PM, right? And so if I do that, then that will allow me to solve that part of my equation. To get the equation of the line, that is, right? And so now the last little piece that would be missing would be this y-intercept. And you'll remember that in our get ready skills, the only thing that we needed to do if we had the slope was we need one other coordinate. So we're going to plug in one other coordinate on that line to solve for b. So I would say sub in a coordinate to solve for b. So those are my strategies. That's my plan of action towards solving and determining the equation for that median PM. Okay, so just to recap real quick, I'm going to find the midpoint. Why am I finding the midpoint? I'm finding the midpoint because then that allows me to have two separate coordinates on that line. And once I have two coordinates on that line, I can find out my slope. Now, once I have my slope, I can input that value into the equation. And then by knowing one other coordinate, I'm going to use P, and I sub in that for X and for Y in my new equation where I have found the slope, and that's going to allow me to solve for my unknown B. Now, if you're not quite there yet, that's totally fine because this is a multi-layered question. I'm going to break it down for you by showing you the steps, and we're going to go through this. All right, so let me just start by, I'm going to create a little bit of a space here for us. All right, so the first thing I'm going to do, let's find the midpoint of QR. So pause the video, go through that, and then we'll come back and double check our answers together. Okay, so I've gone ahead and I've calculated the midpoint of QR, and I found it to be 5 and 2. And so I find just generally in these problems, because they get to be complicated, it's helpful to have that diagram and to input the information there for yourself. So now that I've done that, I'm ready to move on to phase 2 of my problem solving, which was to find the slope of PM. So I'd like to do that with you right now. So let's do that. So pause the video, take a minute to calculate the slope of PM. Okay, so I've gone ahead and done that calculation, so you should check your work as well. Here I ended up with 2 over 7 as my slope. So if I'm, that's one of the pieces that I need in order to solve for the equation of that median, which is our ultimate goal. So let's take a look at step 3. So our final step was to substitute in a coordinate to solve for b. Before I do that, I'm just going to get us up to speed here. So far in our equation, y equals mx plus b, we know that m, that slope, has a value of 2 over 7. And then so that's x plus b. That's where we are so far. So when I say sub in a coordinate, that means, I know that if there's a point that's on this line, an xy coordinate, it should work for this equation, and that will allow me to solve for b. So the coordinate I'm going to choose to use is this guy right here, p. So just going back and substituting that in, I'm going to put in 0 for y, 2/7 times -2, and then plus b. I'm going to clean this up. 0 equals. So remember, I'm just going to multiply this fraction. That's going to give me -4 over 7, just multiplying the 2 times the -2, remembering this is like a fraction over 1, and then the 7 and the 1, if you need to see that, and then plus b. So now I'm going to isolate b by taking this -4/7 and moving it to the other side, and that will give me that b is equal to 4/7. So now, 4 over 7. So now I have all the information I need. I'm going to create a nice box here to highlight what the equation of my line is. And so putting all of those pieces together, just because I've done these 3 steps, the last thing I need to do is put all of the pieces together. So my equation is y equals, and I have that slope value of 2 over 7, x plus, and now I have my y-intercept, which was 4/7, and I am done. That's it. So I'll be assigning some practice questions for this. Feel free to, maybe take out or cull some questions as you see fit based on what you are comfortable with. If you need more practice, certainly the textbook provides a lot of practice over and above the questions I assigned. So, self-regulate around that, know what you need to do to be able to have some mastery of these skills, and as always, reach out for help.